Sensing user activities has long been researched as a key enabler in applications, such as personal informatics, mobile health, and context-aware computing. Our observation is that sensing hand activities could be equivalent to sensing objects that are touched, gripped, and grasped by users' hands. For example, if a wearable senses that its wearers are engaged with a steering wheel, they most likely are driving. Similarly, tools like screwdrivers and saws indicate fabrication works, while cookwares imply cooking activities. We propose TextureSight, a ring sensor that recognizes hand-engaged objects by sensing their textures using laser speckle imaging. Most everyday objects feature unique combinations of surface color, specularity, and roughness, all of which constitute texture information that could be detected by laser speckle imaging. When reflected from rough surfaces, laser beams interfere constructively and destructively in the free space, forming up bright and dark regions, which are called laser speckles. The speckle characteristics, such as size and shape, contain unique information of the surface roughness, while the distance between bright speckles reflect the color and specularity of the surface. We developed TextureSight using two lasers of different wavelengths to unveil more information about surface textures than laser speckle images from a single laser. We instrumented both laser diodes and a small CCD sensor on a 3D printed ring prototype. The two laser diodes are turned on alternatively, and the CCD sensor captures laser speckle images and streams them to a laptop for deep learning inference. We conducted a user study of 11 participants using 20 test objects elicited from a survey study. Overall, our sensor achieved an average accuracy of 88.2% with a user-independent deep learning model. We demonstrate several use cases of TextureSight. First, detected textures could be translated into user activities, the logging of which could power applications of personal informatics. In this example, TextureSight could keep track of which type of activities its wearer has been doing and for how long. With TextureSight, smart environments could better assist users with tasks after acquiring their activity information, enabling applications of context-aware computing. For example, speakers in the room could be muted once TextureSight detects a user's grasp on a presentation remote. Similarly, in a home environment, lights could be automatically dimmed once TextureSight detects a user's grasp of a pillow. Hand tools are often made of different materials or same materials with different colors and surface textures. TextureSight could detect which tool is currently used by the user to allow smart devices, such as a smart speaker, to provide in-situ instructions for training purposes or DIY projects, like the furniture assembly example shown here. TextureSight could also recognize surfaces of fruits and vegetables to facilitate food journals. In this example, a student on a field trip could use TextureSight as an always available alert to recognize plants that could be poisonous for educational purposes. Beyond passively detecting textures, we could also actively assign them as a way of encoding information. In this example, we used white tapes commonly found on the market as a proof-of-concept texture ID tags. The smart ring on which TextureSight resides could function as a key in authentication applications. In this example, the smart ring could unlock the door once it detects its user's grasp on the door handle, which has a unique texture coded to the front door. TextureSight could also recognize a wide array of textures out of the box without the need for collecting personal data. Even for collecting personal data, our work is compatible with the clustering technique shown in the prior work to lower the effort in user labeling. Returning to our previous example, TextureSight could cluster data points from unseen surfaces and wait the user to label these data points later, after clusters are formed. This labeling only needs to be done once. Please refer to our paper for more details.